The complex is a 0. And its conjugate is a 0. I'm glad I went back and foiled that out because I wouldn't have found it. We don't use this a whole lot. Yeah. So -4 and 3 plus I just means that, so scratch your notes out that you wrote to start with. Just means that -4 is a 0, 3 plus I is a 0, and 3 minus I is a 0. Because that's the conjugate. You change the sign inside. So now it's x plus 4, x minus 3 plus I. I did. I know, I said I'm sorry. Terrible. You should have seen calculus this morning. I did one completely wrong calculus this morning. And I couldn't truncate. They're both factors. They're both zeros. Now if you multiply it out, the I should go away. No, you didn't do your homework wrong. Your homework was right. This is only with complex numbers. Oh, well, you wouldn't have known that yet. Okay. Well, it's okay. Huh? It should, yes, whenever you foil it, what should happen, and no, I'm not going to do that. I was going to leave the chunks in there and distribute the chunks, but I won't. X squared minus 3x. Oh. You have to have thick and chunky salsa with them, though. Okay. Next term, -3. And then the I. I'm sorry I messed up to start with. So, x squared, then I've got minus 6x. That's those two. The xi's cancel. The 3i's cancel. Negative I squared is just +1, and I get +10. Yes. All you got to remember is that I squared changes the sign of the number that it's hooked with. So 5i squared is -5. -3i squared is +3. I squared is -1. Negative I squared would be +1. All it does is change the sign of the number and go away. Yep. Yep. But just to show you why they go away, that shows you how much we use it, that I couldn't even remember how to do it. All right, on to the good stuff. Huh? No. That was just the one little thing that I was going to do today, but really, there's no sense in spending a whole day on just that one concept. All right, y'all ready for the good stuff? Y'all gonna remember this? Star this in your notes, highlight it or something so you remember. Okay. Good stuff coming up. Well, there's only one new thing to this, but I'm going to go out on a limb and say you don't remember how to do all the steps to rational functions. What do I mean when I say rational functions? What's rational? Give me another word for rational. Fraction. I said fraction. Fraction is right. So I'm talking about graphing these functions that are in fractions. Okay? What's embarrassing? I'm embarrassing. I do embarrass myself a lot, but okay. Let me just start, I suppose, with an example and run through what we do so that it kind of refreshes. No, I'm thinking. No, it's not. No, I didn't want to do that one. No, I don't want to do that. Okay. No. Okay. Let's run through what we do. Does anybody remember anything we do whenever we graph something like this? Factor. I definitely need to factor. We never get away from factoring. Dang it. Just make this minus and this plus. Y'all are making me nervous. X plus 6. I know, but then my bottom's going to be wrong. Just make that one. I'm tripping. Yay, day. All right, we always want to factor everything. That's always what we want to do to start with. But there are several things we need to look for with rational functions. Do you remember what they are? I'm going to just tell y'all. All right, and actually what I'm going to do is I'm going to run through on here the analysis and remind you how to do each one of them. Ready? All right, how do I find the x-intercept first? My calculator. Without a calculator. Without a y to 0, but this is a little bit more difficult because if I just set it equal to 0. Oh my goodness. All right. I'm going to set well, this would be a non-calculator. These will be non-calculator for the graphing rational. So set the top equal to 0 and solve. The reason for that is, you're right, I need to know when the y equals 0. But if I set this whole equation equal to 0, well, the only way, remember whenever we're multiplying two things to give us 0, one or both of them are 0? Well, if we're dividing and it equals 0, that only happens if the top of the fraction is 0. If the bottom of the fraction is 0, I'm undefined. Set the top equal to 0 and solve. That's all you need to know. So for this one, right, X plus 6 times x minus 1 equals 0. This one's crossing the x-axis twice. What are the two places? -6 and 1. But would you have known they were x-intercepts? Okay. We will, but not yet. Well, because it's going to impact the analysis is why we can't. All right. We haven't done it yet. How do you find the y-intercept? Set x equal to 0 and find it. If I put 0 up here, I end up with -6 over -1, which is look at the equation. 0, 0, 0. I get -6 over -1. Right, because essentially you're doing the whole thing, but the only way that this equation is going to equal 0 is if the top is 0. All right, is everybody with me? What? I'm not going to lie, I'm a little taken aback that we're confused where we are right now, but it's okay. All right. All right, listen. Well, it's not going to do you any good to, and I'm not sure what you mean by solving the problem. Are we not graphing it? Yes, we're graphing it. So we would graph x equals -6 and x equals 1. We would graph y equals 6. Those are points on the graph. We're literally finding the points on the graph is what we're doing. This is how we find the points to graph. Yes. Okay. And I'm just running through over here. And the reason I haven't graphed it yet is this is not always the order that we graph it in. You can graph it in any order you want. I like to find the asymptotes before I graph anything. That's just the way I like to roll. But whatever. All right. So that brings us to vertical asymptotes and horizontal asymptotes and holes. And I'm going to come back to the slant asymptotes because that's the new stuff. Okay. All right. Horizontal asymptotes. Do y'all remember how to find? That's vertical asymptotes. You can. Y'all obviously do not remember this. I remember that. Okay. I'm looking at the degree of the top as compared to the degree of the bottom. Okay. If the degree of the top is bigger than the degree of the bottom, I say it's top heavy, and that's just a little thing to help you remember, right? And if it's top heavy, there's no horizontal asymptote. The degree of the top. This one will be top heavy, that's correct. Yes. That's why I said we can factor it, but we don't want to cancel stuff out yet, because for some of the analysis, we'll use the factored form. For other of the analysis, we'll use the well, you won't have a calculator. Yes, you will. Yeah. This is how you graph it, because you'd have to put the asymptotes on there. Biggest exponent. We'll start, once we get to a point in here, it's like that because we start getting you ready for calculus, and half of calculus is non-calculator, and the other half is. I still have to get you ready. It's pre-calculus. Calculus. Okay. Here we go. Bottom heavy. If it's bottom heavy, then y equals 0 is your horizontal asymptote. If it's bottom heavy, in other words, the degree in the bottom is bigger than the degree in the top, then y equals 0, which is a horizontal line at the axis. That's right. Then y equals 0 is your horizontal asymptote. Actually, right. None. That's right. No horizontal asymptote. Now, if they are the same, oh Lord, y'all try not to yell and scream whenever I tell you this. Okay. Then y equals the leading coefficient of the top divided by the leading coefficient of the bottom. Well, they're not the same on this one.
Oh, I know what you're saying.
So if it was something like 5x cubed plus 7 over 2x cubed minus 1, then it'd be 5 over 2. No, they're not the same, right? You have to determine, is it top heavy, bottom heavy, or the same? It can only be one of those scenarios. Are y'all with me? No? We're looking at the degree of the top as compared to the degree of the bottom. Right. If the degree is bigger up top, it's top heavy. The degree is bigger on the bottom, it's bottom heavy. And then, of course, same means they're the same thing. Okay? Y'all clearly do not remember this from last year. Okay. Okay. Now we need to look at vertical asymptotes versus holes. Okay. H-O-L-E. I'm going to do holes first, and then I'll jump over to vertical asymptote. Here's when holes happen. No, because this is from Algebra 2, so I don't have really a paper for this for you. Oh, yeah, see, the last line is holes. All right, here's when holes happen. Holes happen at places where factors cancel, top and bottom. But if you plug into the original equation, it would make the bottom equal to 0. In other words, look at the equation that I'm given here, right, that I started with. It was, I gotta look at it real quick, y'all, I'm sorry. I gotta scroll up just a little bit. X5 minus 6. And we factored this instead. It's the same thing as x plus 6, x minus 1 over x minus 1. Do you see that this factor cancels? Yeah. Because it cancels out, it creates a hole. The hole happens where this bottom equals 0. So this particular one would have a hole at 1. Where they both cancel. Yes. So it's a hole at 1. Yes. Yep. I would be going along and then I go, oh, wait, I have a hole. That's literally what a hole looks like. No. Now, this has a y value that goes with it. It's not on the x-intercept. We didn't have on this one. Oh, it would happen. Yeah, it's going to happen on the axis. It's okay. It's okay. So now I would have to go back and say, but wait, one's a whole. Right. Right. It can't be both. Yep. Yep. I tried to get an example that would hit on everything, but then some things start overlapping. So no, it can't be an x-intercept because it's a whole. Right, because it's not there. But that is happening on the x-axis. All right, are y'all with me? Okay, vertical asymptotes. Vertical asymptotes. Vertical asymptotes happen every place the bottom equals 0, but not anywhere where there was a hole. Okay, so if there's a hole, it's not a vertical asymptote. So let's say I had x plus 1, x minus 5 over x minus 5, x plus 2. Well, for this one, I'd have a hole at 5, but I'd have a vertical asymptote at -2. See the difference?
No.
There's none for the last one. None.
Why is there vertical
-2. If I set this equal to 0, remember your zero product property. So I go x equals 5, x equals -2, but it can't be 5 because that's a hole. If there is no other, they're both vertical asymptotes.
What if there's only one that?
Oh no, then there's no vertical asymptote. No holes on this one. 2 vertical asymptotes happening at x equals 3 and x equals -2. All right. Now the new one. Slant. Okay, so that's all what we did all these in algebra 2. I know y'all don't. Oh, is that Madison? She's just in time for the new one. Just in time for the new part. You can throw it away. I don't need it. Thank you. All right. Slant asymptote. Okay. So now we don't just have vertical and horizontals. Yay! Slant, we have diagonal asymptotes. Now, we didn't do this last year. This is new. It doesn't always happen. But here's when it happens. Happens only when the degree of the top is exactly 1 more than the degree, yes, than the degree of the bottom. Yes, but because I had something that canceled out, it's not going to work to do this. All right. We decided to skip that lesson and do what we were going to do tomorrow. And we're not going to have the test tomorrow. More learning. Okay. We'll bring it all together with an example. All right, so you haven't asked me the important question. If you know you have it, how do you know where it is? How did you know? You will get a remainder for these. Ignore that. Hopefully I can do synthetic division, but if I can't, I will have to do long division. Slant asymptotes are a lot of work.
Oh, I'll put one after that. That's a lot.
This is number 1 on your homework.
Let's do one together. We're doing number one.
Let's do number 1 on our homework.
Should we do number 1 or should we do a different one?
How about we do, I don't know, number 4. Yeah, do number 4. Have a slant asymptote. Or number 5. Or number 8. I don't know what.
Let me make sure this is going to do everything I want it to do before we decide.
It's the code. 4 has 1, 1 has 1, 2 has 1. So I tried for page. Yeah, try first page. Yeah, everything, I think they all have it except 5. 5 doesn't have 1. Everything else has 1. Okay. I thought they weren't happening that much. No, I thought they weren't that popular.
That's because this look at the title of this homework. Remember, everything else was algebra 2 except the slant asymptote. By the way, that's another word for slant asymptote is oblique. All right, ready? Ready? Okay. All right. I'm going to go ahead and factor what I can, but I'm going to keep referencing this. Remember, some of this analysis uses the unfactored equation and some of it uses the factored equation. Huh? Slant, I can actually use the factored. I'm just going to need it for the holes, really. All right. I'm going to take an x squared out of the top. It leaves me with 3x plus 2. I'm going to take an x out of the bottom. It's going to leave me with x plus 1, which tells me that an x cancels. We plug these holes in calculus, so you have to be able to find them easily now. We have to make it continuous.
So wait, so x is a whole?
Not x. Y'all are jumping ahead. Let's stop. 0, yeah. Okay, so let's look at what we got. I always start with my asymptotes. That's just where I like to start. You can start wherever you like. I like to start with my ha's and vah's. Am I top heavy, bottom heavy, or same? Top heavy, which means I have no horizontal asymptote. How about vertical asymptotes? -1. Why is it not 0?
Why?
Because 0 is a whole.
Why 0 is a whole?
So it just be negative.
There's y0 as a whole. Canceled out top and bottom, so what made it 0 on the bottom? It would be when x is 0. All right. This cancels, right? Because it cancels top and bottom, it creates a hole. Where does it create a hole? It creates a hole wherever the bottom would be 0 of whatever cancels. So whatever canceled out, set it equal to 0, and that's the hole.
Or actually, let's just x plus 1 on top. So if you cancel out those, it's x plus 1 equals 0.
Right, so x equals -1 would be a hole. That's correct. What?
No matter what stage of time, if you cancel something out that equals it's a whole.
Yes. All right. Stella, you put the glasses on. You're serious now? Okay. Slant asymptote. That only occurs when the numerator has 1 degree higher than the denominator. So does this one have a slant? Yes, this one has a slant. So I need to figure it out. How am I going to figure out a slant? I'm going to do a division problem. Now, for this one, I can use the problem that I've already canceled something out in, and it's okay. You can. The only thing is the top can't be factored whenever I divide, right? So I'm going to have to undo that kind of factorization. So either go from the original and divide out, or come here and remultiply the top to divide. So really what I'm doing is I'm doing 3x squared plus 2x divided by x plus 1. This sets me up very nicely for a synthetic division problem because I'm just dividing by x plus a number. Yes. Well, no, you'll have to multiply the bottom out as well if there's more than one piece in it. Right? Like if this was, so if it was x plus 2, x minus 3 over x plus 2, x plus 1, x minus 5, these cancel, but whenever I go to divide, I would need to multiply this out to do it. You see what I'm saying? No. It needs to be multiplied out whenever you divide. If that confuses you, go back to the very first one and divide that. What'd you ask? Okay. Which x are you talking about? You just don't have to. It's just making my division a little bit easier. If I left it originally like this, I'd have to use long division. The way it's set up here, I can use synthetic. It's just a preference, whichever you prefer. All right, so let's see. -1, 3, 2, 0, 3, -3, -1. This doesn't matter, so I'm not going to worry about remainder. So I get that this has a slant asymptote at y equals 3x minus 1. It is a line, as it should be. That's an asymptote. So graph it, but graph it dashed because it's an asymptote. Don't look so taken aback. It's just a line, right? It has a y-intercept of -1. And it has a slope of 3. Up, 1, 2, 3. Over 1. That's my vertical asymptote I found. It bounds this graph. What I'm thinking this graph is going to do is something like this and hug both of these asymptotes this way, but I'll have to wait until I graph it to see. Finding the slant asymptote. Because see that vertical asymptote is bounding it up and down, but that slant asymptote is going to My what?
Your line is curved.
No, it's not. What?
That's an X. It's like you.
Okay. Is everybody okay? All we've done is asymptotes. Vertical, horizontal, and slant. That's it. We haven't done anything else. And hole. Well, no, we have a hole at 0. Has what? The 0 is a hole. Okay, what does the hole look like on the graph? Let's graph it. At x equals 0, at x equals 0, what is y? If you plug 0 into the original equation or into the factored, it doesn't matter. You get 0 back out, right? That means at 0, 0, there's a hole. Yep.
So the -1 vertical asymptote came from x plus 1 equals 0. You take the denominator, set it 0.
And as long as it's not a hole, it's a vertical asymptote. Okay.
So what else do we have to graph? Have we graphed everything?
We haven't graphed everything. Where's my x-intercept? Where does it cross the x-axis? Hole's at 0, so that doesn't count. Where else is it? -2/3. Okay? -2/3 is happening. So this is 1, so about right here. But where does that equal 0? Well, that equals 0 at x equals 0 or at 3x plus 2 equals 0, but that doesn't count because that's a hole. Yeah. Well, if it cancels out top and bottom, it's a hole. All right. Y-intercept. Where's the y-intercept? It's a hole. It's 0. It's a hole, so I don't have to worry about it. So no y-intercept either because it's a hole. All right. Now's the point. None. Now's the point in time where I just have to get, and I'm not going to make you do this part by hand. I'm going to let you use the table on your calculator because otherwise you're going to be here all day and night trying to find points. You need enough points to pick up the pattern, and since I'm letting you use your calculator to do it, I expect you to use more than what you'd have to have by hand. So I want enough to pick up. What I'm thinking is happening is this is probably hugging this, coming down, coming back up, jumping through that hole and doing this, and it's going to reflect here in this one. But enter and be very careful as you enter in. Your calculator is not going to show the holes. Your calculator is only going to show it go through. I was right at how it looks. It doesn't matter. Well, no, do the original. Do the original so it'll show up though. That way, whenever you go to your table, at least at the holes, it'll tell you that it's undefined. Yes. There's none. It's a hole. It said no, none. How'd I do it? So it's top divided by bottom. Y'all need me to do it and project it up here? Yes, that's the bottom equal to 0. Why does 0 have an error? There's a hole there. That's exactly right. Enough to pick up the pattern. So you see how it's dipping down? It has almost a minimum there. Do enough to pick that up. Don't have a what? What you talking about on the graph on the paper? Or Wait a minute, in your table? Let me show you how to change it.
It won't let me edit my page.
Let me show you how to change it. Give me this equation.
It's 3x to the third.
What's ooh, my fingers?
No, it has like pi, like
Oh,
3x to the third plus 2x to the second.
we were doing that in first block.
Divided by x to the second plus x.
All right, so if your table's not to where you can input values,
Oh, why does yours look like that?
mine looks different. Some people's calculators will graph asymptotes, some won't. So remember, there's this slant asymptote that's coming through like this. There's a vertical asymptote here.
See that, like, the bottom and then that line that goes up? Mine doesn't do that. Mine goes up that way.
And it should go all the way up. Mine's stopping. That's why you have to really understand what's going on with rationals, because your calculator just, sometimes it'll just.
I know.
All right, go to second window and make sure where it says independent that you are set to ask.
I'm auto.
If it's auto, then it's automatically generating a list of numbers for you. But if it's set to ask, then it'll let you type in whatever you want. So whenever you go second graph, now I can type in if I want. Yeah, yours should already be able to. So if you want to know what's the value at -0.5, we'll type -0.5. Just keep typing ones. It'll keep going forever.
I did 0, 1, 2.
So if I'm looking at this, I'm thinking I probably need -0.5 here. So at -0.5, it's -0.5. It dips down, right? What do you mean? Does if you go second window, does it say ask and then auto? Which one, on the paper?
My thoughts are merged together.
All right, and so now I'm just going to pick up enough, and this is probably enough here because I can see the pattern, right? I can see that it's doing this, and I'm okay with that. And now pick a couple over here, maybe -2 and maybe -3.
Yeah, -2 at 8,
-2's at 8, -3's at 10. So I can see that it's doing this, right? Yeah, it's over there, like under my lunchbox, I think.
Just go down.
Now, we're not done with the hard stuff. What's the domain? I'm leaving out that vertical asymptote. The range is going to be a doozy, though. Here's what I need to do. What do I need to know? Look at you go. I need to know this point and I need to know this point so I can do my range. Yes, use your calculator for sure. Calculate the minimum. You did eat that. So.
No, you already eaten it up. So, how come mine is only going on the top graph?
Keep going to the left and it'll jump down to the bottom one.
On the bottom graph.
You gotta do maximum for the bottom, minimum for the top.
Oh, because the hump is. Hers aren't showing the U's, it's just showing us.
I'll look at it. I'll have to play around with it and remember how to do it on that one. Remember, range is y, so I'm looking at the y values here. So I'm going to take negative 0.536. Oh, wait, this is negative 0.536, isn't it? Yep.
Actually find the hole on the bottom. Or did you just make it better?
Are you talking about the purple circle?
Yeah.
That's her saying you need to find maximum.
If you let your spider jump to the second piece before you hit enter, then it calculates that piece down there is clearly lower. Let me lower my window so you can see. Let me take it down to negative 15. If I'm calculating a minimum and I said left bound and I let my spider jump from here and then he jumped down here, well, that point's lower. So it's not going to work. I have to be up here on this piece whenever I calculate. So I had to do second calculate minimum. All right, where is my spider right now? See where he is? Now watch what happens when he gets there. Now he's jumped down to negative 19, which is way lower. I've jumped down to this other piece. So I need to make sure I'm in the first piece, hit enter, and then go to the right. For minimum on this piece here. You'll do, so you need the maximum of the bottom, the minimum of the top. Uh-oh. See, I just did it. I just let my, wait, what? There we go. So this point is negative 1.577, negative 7.464. Why don't you let every one represent a half instead of one? You see what I'm saying? Or let every four represent. So there you go. Negative infinity up to that maximum here, and then remember I'm using the y values, not the x values.
There's a y intercept, but I still put 0 for what I put non.
For what?
On the
None.
Okay, so when is this test?
Next week.
Next week. Okay. So we make it very, I think very slightly off numbers. I just, I didn't know what I did in it.
What? So for the, what'd you say, the y intercept? It doesn't have one then. So if you plug in 0 for x and you get an undefined number, then it doesn't have one. Well, for the slants, this is one I would do x goes into x squared plus 2x minus 3. You'd have to do long division. So x plus 2 is your. All right, so I know that this was a lot. I really didn't anticipate y'all not remembering that much, but it's okay. I know, it's been a while. So here's what I want you to do. Tonight, let's do.
they're not hard, it's a lot.
Let's do odds because that'll give you 4 to do. And we may pick up tomorrow and do the evens. We'll see how it goes. If you hit to where you've spent more than 45 minutes, stop. Huh?
On our homework or one problem?
Okay, let's say an hour on your homework altogether. Stop.
I'm not gonna get one problem done in that.
Wait,
I don't want y'all up all night stressing about this.
That's